So those major components are all expected to have a core value. But the average number I put in there is intended to be indicative of the fact that some number of those cores get lost over multiple rebuilds. You do lose some cores, and they have to be replaced. So some individual cores are replaced, and their value is reflected in the average rebuild cost of the core.
How often do you think such components need to be they are lost? How often they need to be replaced? It's rare, like 10% of the times, 5% of the times.
Well, again, it's going to depend upon population and OEM heavily, and it's why I tried to put some guidance there about what I call potential turns. Michelle, remember that the opening question that I was asked was a pricing for the first rebuild.
Yes.
That was the guidance. So I tried to gear it towards first rebuild price.
Okay.
Now, the reason that that's important, of course, is because if it is proven over a period of time, and we're talking 10, 20 years, we're not talking year on year, but if over a period of time, a particular well-known and common component, like a CAT 3516 cylinder block, if that block is the same block, and you can see the turns that you get out of it, then all kinds of things happen. But mostly what happens is you establish the number of turns that that block can undergo. How many times can the cylinder deck, the head deck, where the head bolts to the block, how many times can that surface be repaired, built up, remachined, before finally, when they take that block apart, when they get it into the rebuild shop and they take it apart, they measure everything. And then they have rebuild specifications that says, oh, whether it was 1 turn, 3 turns, 5 turns, or whatever, they will look at those rebuild spec numbers and say, this core is no good. We can't repair this core back to a standard. So we can't do it. So therefore, that's the loss of the core. It's now gone. And over these same numbers of years, that process of bringing a serial numbered block in and a serial numbered crank and looking at how many turns, it may last only once. And whatever caused it to come in to be rebuilt, that's it. Sorry, you lost your block on the first turn. Or with certain amount of good luck, good care, and certain other factors, lots of other factors, that block might turn what used to be the average for a CAT 3516 of 5 to 6 turns. You could reasonably expect that within your fleet, once you owned that casting, once you bought that block, then that block could be turned 5 and 6 turns. What happened with the CAT 3516s is over a period of years, as they continued to change the horsepower and torque, even in the same application being a haul truck, we found out that there was a downward trend. Instead of going 5 or 6 turns, which we used to expect, we started getting down into the 2 and 3 turns. They keep hanging more stuff on the top of the block, and it's got to be held securely with the head bolts. Well, the head moves. As it frets and moves, and everything's moving and expanding and contracting in there, we started finding out that our blocks were only lasting 2 turns if we were lucky. That's without catastrophic failure. That's just a rebuild. In addressing that with Caterpillar, their final response is 3 years ago, they started working on and have now released what they call the E-Series block for a 3516 engine. That new block has, for instance, instead of head bolts that were 10.5 inches long, those head bolts have now been increased almost to 12 inches long. So the casting in the block had to be made longer. They had to redesign it, recast it, age it, machine it, put it into the marketplace. We now have an expectation that that block will last longer. Now, whether that proves out or not, darned if I know. But that's the expectation. So those major components, the numbers that I've provided there, I've made an effort to give an average expectation of rebuild costs that includes some numbers of failed components that are no longer any good, that have to be removed from the core bank.
Okay, for the first rebuild, but the cost for a second rebuild would be significantly higher, like.
Well, not necessarily. And that's what I also tried to say there in one of the sections where I noted that there is no solid technical reason why a second, third, fourth, fifth, or sixth rebuild has to cost any more than the first one. However, there's even the belief and the actual reality, because we've seen it, that brand new engines from the OEM appear to last longer than a first rebuild. So on an operating cost per hour, you get 20,000 hours out of your brand new engine in a brand new haul truck, but your first rebuild only gave you 18,000 hours. There is a reality that is there. However, if you look at the rebuild practices and you try to find out, well, why is that true? Why can you not rebuild an engine back to the same durability as a brand new one? There is no good technical reason why that should not be true. But it appears that secondary and third rebuilt engines, blocks, cranks, reused components, they appear to not last as long as the OEM. That's a real, that's an observable thing. And you can kind of put a number against it. But there's no good reason why that has to be true. And nobody can tell you why it's true, but it appears to be true.
Okay. So basically, the work like rehardening, recoating, rechroming is done on the most essential components. Then the failure rate and the cost of the second and third rebuild should not ideally be higher.
Correct. Arguably, it shouldn't.
Okay.
But we already know that the difference between a brand new one and that first rebuild for durability, which means how many hours before I have to do it again, those numbers reflect that the new one, it lasts longer. Once you get beyond the first rebuild, there really should not be any difference between the first, second, third, fourth, and fifth turn. There really shouldn't. It is so heavily driven by what the customer is willing to pay for and the expertise of the rebuild facility. And there are some big differences. Even within, for instance, you might have a tendency to think that all Caterpillar dealers rebuilding Cat 3516 engines, they're all equal. Contraire. Not true. You go to one Caterpillar OEM dealer and he has these rebuild practices for his customers, and you go to another one and it's like, well, you're not even doing the same thing.
Okay. Hello, can you hear me? Can you
Yes,
hear?
yep, I'm fine.
Okay. I thought I lost you. Okay, and that's true also for MTU and for the other big player. Like I know the third big one is Cummins. They also have significant differences between different dealers, or there is more like Caterpillar is the biggest one, so there are more differences basically.
I think you're right there. Caterpillar is bigger, and therefore there's more opportunity for discrepancies. MTU specifically is a different entity. For instance, they have a different business operating model coming out of Germany to start with, and their engineering practices carry over dramatically. From what we can see, the influence of MTU, quote unquote, German engineering isn't only for that first engine. They've carried a lot of those standards and their details in building over into their secondary rebuilds, their first turns, second turns, etc. Now, here in North America, we don't have a lot of these big high dollar and high horsepower MTU engines out there for us to see very well. And we also know that MTU struggles with Americans' concept and acceptability of quality compared to what German engineering has specified. The MTU guys, they've made a business relationship with Detroit Diesel. That's why technically in America, the MTUs are MTU Detroit Diesels. And MTU used some of the things that Detroit Diesel had, such as Detroit Diesel's engineering knowledge and everything, and the accessory equipment to adjust to exhaust emissions. MTU didn't have that in Germany. They weren't forced to the same EPA standards that they were in the U.S., so they didn't really have that as developed. But Detroit Diesel did, so therefore they relied upon that. But what they also found out, and we know this just from experience in the industry, that MTU would look at what Detroit Diesel rebuild practices are in their shop and just go, well, you can't rebuild my MTU engine like you rebuild your Detroit Diesel 149 TA that you used to rebuild. You have to change Detroit Diesel because our engines will not allow you to have that level of rebuilds. You have to do it this way. So MTU has had to work with these various dealers across North America in order to build secondary reman engines that meet MTU concerns and MTU engineering. That meant tooling, that meant training, that meant parts availability, that meant specifications to condemn one component versus another. So what I'm trying to infer here is that if you tried to compare an MTU 16V 4000 crankshaft compared to a Caterpillar 16V 3516 crankshaft, or even a C175, which is more comparable to it, and if you tried to do that, you may find that the measurements that are the specification for a condemning limit in the Cat engine allows the crankshaft to be rehardened, resurfaced, and put back into service. But if you look at the MTU spec, nope, sorry, you buy a new crank.
Yeah, I've been told by some people. I spoke with some people in the last few days, and I've been told that roughly speaking, MTU engines are more expensive and more complicated. So the cost of the maintenance cost and the cost of parts is more expensive, and oftentimes you cannot replace the parts. You cannot fix the parts. You have to replace them. But
that's correct.
The big advantage is that they save fuel for the client.
I would stay away from the fuel economy argument and just say that the overall cost of ownership, because mostly driven by what I tried to reflect in down along line 66.
Okay.
Is that the expected life and therefore the operating hours between turns is generally thought that you will get more operated hours between turns out of an MTU engine than you will out of, for instance, a CAT C175. The reason for that is thought to be, and it's a terrible alliteration, but it's thought to be more like, well, that's that German engineering, that we all talk about. That's why a Mercedes car is better than a Ford. It's very generalized, tied toward that. Mm-hmm. But the numbers do show kind of what I wrote right here, that you can have that as an expectation. However, when you go to pay the price for that MTU engine, even though you can expect it to run longer, your real interest is overall cost of ownership. Mm-hmm. Fuel, leave it out of the equation for the moment. It's not the fuel. The fundamentals of fuel are a whole different discussion. So stay away from fuel. Mm-hmm. But when you pay that bill to MTU/Detroit Diesel to rebuild your engine, and you see that as a higher cost, which I have tried to reflect here, mm-hmm. Here's another major background thing. Even though you're dealing with a North American entity called MTU Detroit Diesel, a huge part of the cost is tied to the European Union/Germany. Mm-hmm. And then you have to deal with the reality of profits and all this other stuff that goes into it, including a huge factor, which is the value of money mm-hmm. across the markets. Mm-hmm. The American dollar goes up and down in value. And it is referenced, for instance, today, you can look at the euro at $1.16 of $1 US dollar. Mm-hmm. Well, what do you think that did when it was $1.47 mm-hmm. US dollar to equal 1 euro? Mm-hmm. Well, it's a big, big factor. And it's hidden in the background, but I assure you it's part of the drivers, because the marketing for that MTU engineered, built, designed, and all of those components, by the way, are cast and machined in Germany. They're not cast and machined in the U.S. Even though you may rebuild the engine in the U.S., if you're going to build it to the MTU specs, which are German-oriented, and you're going to buy new castings, etc., based upon the American dollar being sold to Germany for that part, mm-hmm. and the cost of that part, therefore related to it. And my goodness, now you're into a world of stuff that maybe is your world, but it ain't mine.
Okay, I understand. Another question I have is about how companies choose between the rebuild of their own engine and the service exchange engine, so a reman engine. Why do some companies or a company sometimes choose to rebuild their own engines, and sometimes they just get an exchange engine?
Well, yeah, there's a lot of reasons why a company would do it. The company I worked for, they tried it for years, thought that they could do it. Some of it has to do with trying to bring the OEM to the table for more competitive services. Sometimes it's real simple. They simply can't get the service out of the dealer that they need to run their business model. Mm-hmm. We have a saying that basically says, if you can't do it yourself for a better cost, hire somebody else to do it. Mm-hmm. So it's really simple in that. But there's a lot of reasons why a company would try it. They might do it in one engine model, but not try it in another. They might have been able to successfully negotiate a new fleet of equipment that includes future rebuilds under certain conditions, but they couldn't do that for some of their older equipment. There's in the particularly Caterpillar world, but there are also these kind of agreements with other OEMs and dealers. We have what's called MARC agreements. They're mm-hmm. maintenance yes. arrangements. Mm-hmm. And so when you get into them, if you can't get if you're a customer and you can't get what you need to meet your business model, then one portion of the business or another may say, look, I can do that. I have internal square footage in my shops. I have the tooling. I've been able to hire people. You know, a cat dealership collapsed in my region, and all of his employees and a lot of his machinery I can buy. Mm-hmm. So he buys them and he puts them into his facility and starts rebuilding engines.
I see.
It has become the long-term trend, Michelle, though, is not in that direction. The long-term trend is further outsourcing. I would suggest look at what I said about the Australian marketplace and see the direction that the North American marketplace is headed towards.
Okay. When we look at the difference between a remanufactured engine and a rebuild engine, there is a difference in terms of price, and this difference is not reflected, as far as I understand, in terms of in the quality of the engine, number of life hours and performance of the engine. So the trade-off must be in terms of time, I guess. If you rebuild, basically, if you do the rebuild of the same engine, then you cannot use that engine for a long time. While if you buy a remanufactured engine, an external engine, then you can replace it immediately, basically.
Well, that timeliness is certainly a big factor. As long as that haul truck, for instance, is sitting on the ground with no engine in it, you're bearing a cost that you're not going to be happy with. Mm-hmm. So sometimes you pay more in order to get the reman engine because it's readily available. Mm-hmm. It is heavily influenced by make, model, application, and population within your region and your working relationship with the dealer. I did put in a fairly significant 15% to even 15% difference between mm-hmm. rebuilds and reman, yes. because I was trying to emphasize not only the difference between basically CAT and MTU, which is obvious, that's basically a 5% variable, mm-hmm. but reman rebuild is can be significant in that. Now, reman is predominantly a warranty that comes directly from the OEM, because if it is a reman engine, that means it was built by the OEM remanufacturing facility, mm-hmm. whereas a rebuild is dealer driven. Mm-hmm. A large part of that 15% difference between reman and rebuild is probably related, in my mind, is related to the business relationship between a customer that wants somebody to rebuild his engine and what he's done. And he's doing that for a reason. Well, it's cost. He can get it rebuilt locally, for instance, at the dealership, as opposed to the reman engine. When Caterpillar might be rebuilt, their reman facility might not only be in Indiana, mm-hmm. or it could be in Mexico. Mm-hmm. So there is a real cost there. Am I exactly right at 15%? I don't know, because it's still within the 20% variable after all of my prices, just as an average. Mm-hmm. But I did want to emphasize that you can logically expect that rebuilds will be at a lower premium than a reman.
Then at this point, my question would be like, the rebuild option looks way more way better for a client. Why would anyone choose a reman if the results in terms of quality are the same and you spend 10-15% more?
The rebuild reason for it and that price attractiveness also reflects the fact that there are two ways in order to own the engine in a rebuild program. So to start with, if you literally own and you're going to have your block rebuilt, then you already own the block. You already own all the hard parts. All you got to do is either have them repaired or rebuilt, and that costs less. However, the reality is, in order to compete against remands which cost more because they typically hold better warranties, slightly improved warranties, and availabilities may or may not be there, which is a risk, then many rebuild programs include pools. So pools of rebuild engines. For instance, you've got one Caterpillar dealer here in the state of Nevada. He has multiple customers, all using the same Cat 3516 engine configurations, the blocks, the cranks, the heads, etc. So where with an individual customer, he might have 50 of them. But if you look in the number of blocks and cranks that the dealer is dealing with, he may have 200 of them. So he is routinely, regularly rebuilding engines, and they are pool engines. So when customer X needs a block, he may not get his block back in quote-unquote a rebuild. So you could call that an exchange. It's a rebuild exchange as opposed to a straight-up rebuild.
Okay.
That would be another category there that can change the pricing.
Okay.
I tried to throw in